Okay, so chapter 7.2, we continue with our graphing, our things related to graphing. Two things we're going to deal with basically in this chapter is to determine whether possible solutions satisfy an equation. That's the first thing. And those will come in the form of ordered pairs. And then we're going to create tables of ordered pairs, and those will begin with an equation. Now, first of all, 3 steps to determine whether an ordered pair is a solution. First thing we need to do is replace the variables with the given values that are supplied. And then step number 2, we're going to simplify our equations using the order of operations. If necessary, some equations may not need to be simplified. And then number 3, here's the big thing. We need to check to see, do the right and left hand sides of the equations, are they equal? If they are equal, we have a solution. If they're not equal, we don't. So we're going to go ahead and test 1 or 2. So we're going to check to see, is the ordered pair 2, 5, is that a solution of this equation, y equals 3 times x plus 2? So step number 1, I need to substitute into the equation. And one thing you'll notice in this case I've color-coded where they should go. Most of the time that's not going to be the case. Please make sure that the x goes into the x position, the y goes into the y position, because if you don't, you're probably going to be off to begin with. And so what we're trying to check here is 3 times 2 plus 2, is that equal to 5? If it is, we have a solution. If it's not, we don't have a solution. So now I'm going to, step number 2, use my order of operations. So 3 times 2 is 6. And I am simplifying down here. I'll bring my 5 down. And then 6 plus 2 is obviously 8. And so you ask yourself, well, is 5 equal to 8? Well, the answer to that, those are obviously not equal. So this is not a solution. S-O-L-U-T-I-O-N. And remember, I'm not very good at writing with a mouse here, so it gets a little bit challenging at times. So 2, 5 in this case is not a solution. All right, same equation, different ordered pair. In this particular case, 3, 11. So y is my, or 11 is my y value, put that in. 3 is my x value, put that in. So substitute in. Yeah, does this stuff equal 11? If it does, 3 times, which using my order of operations, that's 9. 3 times 3 is 9, plus 2 is 11. Well, 11 equals 11, so yes, this is a solution. Now, these were just simple equations, but if you were checking for more complex equations, you'd do the same thing. Put the given values in, and check to see, is the left-hand side equal to the right-hand side? Is there balance? So, all right, now we are going to take an equation. In this case, up here at the top, you'll notice my equation is y equals 8x. And we are going to create a table of ordered pairs. Okay? And we are told that we're going to do. We're going to take these values of x, and we are going to insert them into the equation. We're going to replace them one after another. So you'll notice here I've set up a table. And we're going to put x in, and we're going to see what comes out. Because an equation in many cases is a number generator. So in each of these cases, I'm going to replace x with this value here. So 8 times 1, 8 times 2, 8 times 3, just replacing x with the given value. And then here's, like, again, number in, machine that does the work, y is your output. So 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32. And now that I have a pair, an xy pair, I can write those as an ordered pair. 1, 8. My x value is a 1, my y value is an 8. My x value is a 2, my y value in that case is a 16. So 2, 16. 3, 24. I'm going to rewrite that 3 here. That's a very poorly written 3 here. At least let's see if I can fix it a little bit. 3, 24. And 4, 32. Now, the next step, or one of the steps down the road, is to take these ordered pairs and graph them. on a coordinate plane, but we're not going to worry about that in this particular instance. Okay. So now our equation, n and m in this case are our variables that we're working with instead of x and y, but the same type of thing as we did. We're going to let m be these values. So that makes this column my m column, and we're going to use -4, -3, -2, -1. Our equation is this 4m minus 3 part. Our output is going to be n. I'm putting m in, so what comes out, that will be n. And then our ordered pair, m is going in, n is coming out. All right. But the idea is still the same. I'm going to take these values here in this column. I'm going to put them in. I'm going to replace m in the equation. So I got 4 times -4 minus 3 here. Oh, I'm sorry. 4 times -3 minus 3 here. 4 times -2 minus 3. 4 times -1 minus 3. So I've done the substitution in each case, and we know that multiplication will come before subtraction. So 4 times -4 is -16. -16 minus 3 is -19. And if you want to go ahead, even right now, I'll go ahead and put my ordered pair together. -4, -19. Alright, so in this case, we had -3 in here, so 4 times -3 is -12. -12 minus 3 is -15. And so that gives me an ordered pair of -3, -15. Very poorly written 15. 4 times -2 is -8. So -8 minus 3 is -11. So -2, -11. That computer did not help me on that one. So we'll rewrite that -11. And then 4 times -1 is -4. -4 minus 3 is -7. And so my ordered pair is -1, -7. And again, these ordered pairs could be graphed, if we needed to, on a coordinate plane using our ordered pairs. Which in this case, m would be my x-axis. Okay, so that would, m would go across the x-axis. N would be my vertical axis in that case. Just pointing that out while we're at it. So, all right, time for you to have a little fun on your own. Although obviously, come see me if and when you have any issues. So, good luck.